Myself, Mrs. P. Kanmani, Assistant Professor, Department of Physics, VV Vaniya Perumal College for Women, Virudhunagar. In my previous lecture, we have learnt about electromagnetic radiation. With that understanding of electromagnetic radiation, now let's explore the significant branch of physics and chemistry, that is spectroscopy. Spectroscopy is the study of absorption and emission of light or any other electromagnetic radiation by matter. Let's note the point: light or any other electromagnetic radiation. Now, what is matter? Matter is three types, that is solids, liquids and gases. So, using spectroscopic technique, we are able to study solids, liquids and gases. The pattern we observe due to absorption or emission of light or any other electromagnetic radiation is termed as spectrum. With a detailed dissection or analysis of that spectrum, one can infer the properties of the spectrum. So, in the previous lecture, I say we have understand the electromagnetic radiation. Electromagnetic radiation in the previous lecture, what we have learnt? Electromagnetic radiation is nothing but the oscillation of electric and magnetic field vectors, right? So, by the term oscillation, the other two terms spontaneously come to our mind is frequency and wavelength. So, the electric and magnetic field lines oscillates in all possible frequencies and wavelengths. That is, we have to categorize the electromagnetic radiation. So, this is electromagnetic spectrum, which is categorized using wavelength or frequency. That is, the electromagnetic spectrum spans from longer wavelength region to the shorter wavelength region. In the longer wavelength region, we have radio waves, microwaves, then infrared rays, and then we have some color portion, and then ultraviolet rays, X-rays and gamma rays. That colored portion is what we referred as light. So, what is light? Light is nothing but part of an electromagnetic radiation which is visible to the human eye. Note that point, that is visible to the human eye. So, light is also an electromagnetic radiation. Okay. This electromagnetic radiation holds some energy. Each set of wavelengths have energy. So, the energy of an electromagnetic radiation is inversely proportional to its wavelength. That is, longer wavelength regions have lower energies and shorter wavelength regions have higher energies. Then what is the lower energy? Radio waves. Okay. And what region of electromagnetic radiation is higher energy? X-rays and gamma rays. Okay. Now, why we need spectroscopy? Why we go for spectroscopy? We need to see things to understand how they behave, right? What we physics to do, we have to understand. What or how the matters behave, right? Imagine, let me explain with one example. Imagine you are standing in a dark room and you are given with or provided with two objects, and you are asked to convey information about these objects. Imagine you are in dark room. What are the informations you gather from the objects? You can only feel the objects, right? You cannot see the objects, you can only feel the objects. By that feeling, what informations you can convey? You can convey whether the object is spherical or circular or square in nature. That is, you can convey only the geometrical informations. Now imagine the lights are put on. What are the other informations you can convey about the object? Now you are able to see, or you are able to convey the color of the object and the nature of the object. What is the nature? The object can be either transparent or opaque, right? Transparent, you can see through the object. Opaque, you cannot see through the object. What makes the object see through? The light that is interacting with the object transmitted into the object. In the opaque object, the light is just reflected from the outer surface. So, with that understanding, now we can say interaction is important, right? Once you need information about any object, you need interaction of an electromagnetic radiation. So, this interaction makes ourselves to learn about the properties of any solids, liquids or gases. So, what are about the objects that we cannot see in real life? That is, the objects that are not in the range of our visible light. So, when we are able to see objects in different wavelengths, we can see through the objects. So that is our understanding. What we have understood, using light we can see only a definite range of we can only study definite objects only. Once you need to explore universe or other range, micrometer or nanometer range, you cannot use the visible light, right? For example, in astronomy, gamma ray and X-ray telescopes are used to study massive dying stars, accretion of matter around black holes, and visible light probes the light from the stars, and longer wavelength regions are used to study dusky star forming regions or clouds. So using all that information, that is from longer wavelength region, lower wavelength region, apart from visible light, all other regions of electromagnetic radiation are used to comprehend a picture of the universe. Now let's move on to what are types of interaction and electromagnetic radiations goes with the objects. Once the electromagnetic radiation hits the object, it can either transmitted, reflected, scattered, or absorbed, or emitted. So these all are the things that can happen with the interaction of electromagnetic radiation. The electromagnetic radiation can be absorbed, the electromagnetic radiation can be emitted, the electromagnetic radiation can be transmitted, the electromagnetic radiation can be reflected or either scattered. With that information, that is the absorbed radiation or the emitted radiation or the reflected radiation, we have to gather the information to comprehend a picture of the object, right? What are the different types of spectra? We have broadly classified the spectra into two types, discrete and continuous. Discrete and continuous, and the discrete spectra is again classified into absorption and emission spectra. Now first, the continuous spectrum. The continuous spectrum originates from the very hot objects, that is stars or incandescent lamps. These objects radiate their heat away through the production of light. So they emit frequencies in all possible wavelengths. So the apparent spectrum seems to be smooth and continuous. Then emission spectrum. We all know around the nucleus there are electron clouds which are situated at discrete energy levels. Each set of atoms or each set of elements in the periodic table have discrete energy levels. So the electrons are situated in these discrete energy levels. The nature of all the objects in the universe is to be in the ground state. Once the atom is not in the ground state or in the excited state, there is excess energy. So this energy is to be dumped. What is the way the energy can be dumped? By the emission of electromagnetic radiation. So depending upon the difference between its ground state and excited state, the emitted radiation's wavelength will be the emitted radiation will have its wavelength. So depending upon the energy difference between the ground state and excited state, the emitted electromagnetic radiation can be in microwave region, X-ray region, or in the visible region. Okay, the spectrum obtained in that cases will be emission spectrum. Then what is absorption spectrum? Imagine a star is emitting emitting all possible frequency electromagnetic radiations. Once the radiations reach the earth have its own atmosphere, that is gaseous molecules. These gaseous molecules will have discrete energy levels that we have seen in the previous slide. So these discrete energy levels have some energy. So in the continuous frequencies, depending upon the energy difference, they may absorb some frequencies. So once we see the continuous spectrum of a star, some regions will be black in nature. That means these regions are absorbed by the gaseous molecules in the atmosphere of the earth. So now the spectrum will no longer be a continuous spectrum but a discrete spectrum. So thank you, learners. In this session we have learnt about what is spectroscopy, the need of spectroscopy, and the types of spectra. In the next sessions we will definitely learn what are the different electromagnetic radiations used to probe the different objects. Thank you.